When you open a tin of treacle or a jar of molasses, you get something that doesn't quite behave the way food normally does. It pours too slowly. It clings to the spoon long after you've moved on. It smells of something older and more complex than sugar. Something almost fermented, like the ghost of a process rather than the product itself. You use a tablespoon of it in a recipe and forget about it until the next time you're baking. It is difficult to imagine, standing in a kitchen measuring out that dark, slow-moving tablespoon, that this substance was once among the most economically and politically consequential commodities on Earth, that empires organized their trade routes around it, that a tax on it helped ignite a revolution, and that, on a January morning in Boston, a tank containing 9 million liters of it collapsed without warning and sent a wave of syrup through a densely populated neighborhood, killing 21 people and leaving a trail of destruction that took months to clear. Molasses today is a baking ingredient. For most of recorded history, it was closer to a currency, and understanding the gap between those two versions of the same substance requires going back to the moment sugar itself was first produced at industrial scale. But here's the surprising truth. Molasses was never meant to be valuable. It was the waste left behind after the thing people actually wanted had been extracted. The story of how a refinery byproduct became the engine of transatlantic trade, a tool of political resistance, and eventually the catalyst for one of the strangest industrial disasters in American history, is the story of what happens when an unwanted substance turns out to be more useful than the product it came from. Today, we're uncovering what molasses actually is, how a liquid that nobody wanted ended up driving the slave trade, and why a January morning in 1919 proved that slow and harmless are not the same thing. To understand molasses, you have to start with what sugar cane actually contains. Sugarcane is a tall grass that stores energy in its stalks as sucrose, the same compound found in table sugar. When the cane is harvested and crushed, the extracted juice is a complex mixture of sucrose, water, minerals, amino acids, and other organic compounds that accumulated in the plant over its growing season. Refining that juice into the white crystalline sugar familiar from every kitchen involves a series of boilings. The juice is heated and concentrated until sugar crystals begin to form and can be separated from the remaining liquid by spinning the mixture in a centrifuge. What comes off the centrifuge in two distinct streams is the fundamental division at the heart of the sugar industry: white crystals on one side and a dark, dense, mineral-rich liquid on the other. That liquid is molasses, and it exists because not everything in cane juice will crystallize. The minerals, the organic acids, and the compounds that give the liquid its color and bitterness physically prevent complete crystallization. The more times the remaining liquid is boiled and spun, the more sugar is recovered, and the darker and more concentrated the residual molasses becomes. 3 successive boilings produce 3 distinct grades. The first is light and relatively sweet, the second darker and more bitter, the third so depleted of sugar that it is almost entirely minerals and organic matter, dense and black and barely palatable. That final grade, called blackstrap, is arguably the most nutritionally dense product of the entire sugar process, rich in iron, calcium, and magnesium, and almost entirely ignored for most of its history. Think of it like wringing out a wet cloth. The first squeeze releases most of the water cleanly. The second squeeze gets more, but with more effort. The third squeeze recovers the last of it, but what comes out is different from the first, darker and more concentrated, carrying everything the earlier squeezes left behind. Each grade of molasses is a different squeeze of the same original material. For the early colonial sugar industry, molasses presented an awkward problem. Sugar was the product. Molasses was what was left, and it accumulated faster than any obvious use could absorb it. Caribbean plantations in the 17th century were producing it in quantities that exceeded any local demand. The liquid spoiled if left too long. It took up storage space. It attracted insects. Planters dumped it into the sea, used it to feed livestock, or simply discarded it as the unavoidable residue of the process they were actually being paid to run. Then someone noticed that molasses fermented. The residual sugars in molasses, too bound up with other compounds to crystallize, are still fully accessible to yeast. A mixture of molasses and water, left in a warm environment, ferments within days into a low-alcohol wash that can be distilled into a high-proof spirit. The product of that distillation was rum, and rum transformed the economic status of molasses from waste to raw material almost overnight. By the early 18th century, distilleries in New England were importing Caribbean molasses in enormous quantities, converting it into rum, and selling the finished spirit into markets across the Atlantic world. The triangular trade that followed was one of the most profitable and most brutal commercial systems ever constructed. Molasses moved north from the Caribbean to colonial distilleries. Rum moved east to West Africa, where it was exchanged for enslaved people. Enslaved people were transported west to the Caribbean plantations, where they were forced to harvest the sugar cane that produced the molasses that began the cycle again. The waste product of sugar refining had become load-bearing infrastructure for the entire Atlantic economy. So, if molasses was this economically central, why did the British Parliament's attempt to tax it in 1733 cause such fierce resistance from the American colonies? The answer, as is often the case in history, comes down to who the tax was designed to protect. The Molasses Act was not imposed to raise revenue for the Crown. It was imposed to protect British Caribbean sugar planters from competition with French Caribbean suppliers, whose molasses was cheaper and more abundant. New England distillers had been buying French molasses because it was better value. The act imposed a tariff heavy enough to make that trade uneconomical, effectively forcing the colonists to pay higher prices for British-sourced molasses to protect the profits of a small group of plantation owners. The colonists responded by ignoring the tax almost entirely, developing extensive smuggling networks and treating the act as an example of Parliament legislating in the interests of distant landowners at the expense of colonial commerce. Resentment that would eventually find expression in the Revolution was accumulating around syrup decades before it found expression in tea. The Boston molasses disaster of January 1919 arrived 2 centuries later, at the tail end of a different era, when molasses was being processed at industrial scale for use in industrial alcohol production rather than rum. A storage tank owned by a distilling company, poorly constructed and inadequately inspected despite years of reported leaks, failed on an unseasonably warm afternoon. The wave of syrup that flooded the surrounding streets was moving fast enough to sweep away horses, demolish a fire station, and buckle the supports of an elevated railway. The cleanup took weeks. The legal proceedings took years, eventually establishing the principle that corporations bore liability for damage caused by negligently maintained infrastructure, a precedent with consequences well beyond the specific case. So, the next time you spoon molasses into a mixing bowl and notice how reluctantly it leaves the spoon, you'll know you're handling something with a longer and stranger history than almost anything else in the kitchen. It is what sugar leaves behind when it has taken everything it wants. For most of history, that remainder turned out to be worth more than anyone expected.